Today we're going to be talking about the fundamental theorem of calculus. And we did if this is 2021, we did an activity online and hopefully you got something out of this. And I think I'm going to try and put this video up online at the end of my activity. But by the end of the activity, hopefully you realized what the fundamental theorem of calculus is. I also find it kind of interesting that we're in second semester, almost halfway through the chapter of our book, and we're now at the fundamental theorem of calculus. Okay, so here we go. The fundamental theorem of calculus. So, if f is continuous on a closed interval and big F is the antiderivative of small f on the interval a to b, then the integral from a to b of f of x dx is equal to f of b, big F of b, minus big F of a. Where again, remember, another way of saying this is the derivative of f of x, a big F, is small f. Okay, so we use that antiderivative section that we started off our chapter with. Okay, first example. Take the antiderivative of 3x squared. So that is x to the third, and we're going to evaluate that from -2 to 1. So I plug in 2 minus -1 to the third, and we end up with 9. What function's derivative is cosecant squared? Well, that is negative cotangent theta, and we're going to evaluate that from pi over 3 to pi over 6. So the negative cotangent of pi over 3 minus the negative cotangent of pi over 6. Well, that turns into -√3 over 3 minus a negative, so that's plus √3. So we have a 2√3 over 3. Okay, remember I always struggle with these. Add 1 to the exponent, so that's x to the -1. 1 over your new exponent, evaluated from 1 to 2. So I have -1/2 minus a -1 gets me to 1/2. And then our last example. What function's derivative is this? Well, what that function is the inverse sine of x. So then we do inverse sine of 1/2 minus inverse sine of 0. So at what angle is the sine 1/2? Well, that's going to be at pi over 6. Remember your restrictions, -2 pi to 2, or negative pi over 2 to pi over 2. Inverse sine of 0 is 0, so we get pi over 6. So remember what this all means is this means the area under the curve. The area under this curve, 3x squared, from -1 to 2 is 9. The area under cosecant squared, from pi over 6 to pi over 3 is 2√3 over 3. Again, area. I'm going to stop saying it because you guys will get bored. Okay, so find the area of the region bounded by that graph, the x-axis, and the vertical lines x equals 0 and x equals 2. So I'm looking for the area from 0 to 2 of x cubed over 4 plus 1/2 dx. Don't forget to write that dx in there. Okay, the antiderivative of this. Add 1 to your new exponent, 1 over that exponent, plus 1/2 x, evaluated from 0 to 2. I plug in 2 and I get 2 to the 4th power is 1 plus 1 minus, I still want you guys to be plugging in 0 here because there's eventually going to be some problems where when you plug in 0, it's typically with exponentials, you're going to get 1 as your answer. So still be plugging in the 0 and you're done. Okay, so there is a good application of this, the mean value theorem for integrals. And this is going to lead us into another formula that we use a lot. So basically, there is some value c, okay? So there's some value c where the area at this c equals the area under the curve from a to b. Said another way, the area under the curve from a to b of f of x dx, so the area under the curve equals the area of this rectangle that they have drawn out. So remember, the area of that rectangle is equal to f of c, so my height, times by the width, which is b minus a. And what this actually leads us to is this leads us to this formula, is that there's some value c where the area under the curve is equal to, I shouldn't say this equal to this formula because it's not. But what this means, what this is the average value of f of x over the interval from a to b. And if you think about it, what are the average values? The average values, if I were to add up all these values here, adding up all these values up here. So adding up all of that area under the curve, finding the average value of all those, okay, there's going to be some number c where that average, that's going to give you the average value. Okay, so that's what they're talking about here. Okay, the average value of f of c is the mean value theorem, is also called the average value. Okay, please know this formula, definition of average value. Okay, integral on the closed interval, my average value is given by that function. Okay, let's do an example of this. So I need to find the average value of a function on the interval from 0 to 4. So 1 over 4 minus 0, b minus a, from a to b of my function. Put that whole function in parentheses. Do not forget your dx. Okay, so I have 1/4 2x minus 1/3 x to the third, evaluated from 4 to 0. So I put in 4 and I get 8 minus 4 to the third power is 64 over 3. Minus, if I plug in 0, I get 0. I still want you to plug it in. Please just trust me on this. Doing this in my calculator, I get negative 40 over 3, and that simplifies to negative 10/3. So I think it's interesting that our average value, okay, that's the average of all the values of this function, is negative 10/3. And that is all I have for you on our fundamental theorem of calculus.